Hi, 8th grade. These are your 8-3 notes for today's lesson. I'm going to split these notes into two videos. We're going to start with guided practice 1 and 2, and then the second video will cover guided practice 3. So if you want to follow along with your textbook, this is what's going to be showing up in your homework assignment. So there is a key concept on page 545 of your book. It basically breaks down how the parent function for reciprocal functions work. So a reciprocal function is a special type of rational function. So the parent function is just going to be a 1 over x. We know x can't be 0 because you cannot divide by 0. The family of functions with your a, h, and k, your a being your stretch or shrink or your reflection, your h is your horizontal shift, your k is your vertical shift. The shape of these graphs are going to be called hyperbolas, which is actually going to include two branches of your graph. And we've seen asymptotes before, but what's new with this chapter with rational functions and reciprocal functions is there could actually be horizontal and vertical asymptotes together. So in reciprocal functions, there's going to always be one of each. The vertical asymptote is at the value of h, and that's going to affect your domain, just like we have found in many other functions. Your horizontal asymptote is going to be your k value, and that's going to affect the range. So the first two examples are just to get you comfortable with how the asymptotes work. So guided practice 1, we're just going to determine the value of x for which the function is not defined. Basically, we're listing restrictions in the domain like we did in lesson 8.1 before school closure. In part A, if we look at our denominator and we set that equal to 0, we notice that x cannot equal 1. In part B, if we set the denominator equal to 0, 3x, subtract 2 to the other side, divide by 3, we find that x cannot equal negative 2/3. Okay, so those would be our restrictions. And what we're going to connect with the restrictions now to is our asymptotes. So when we look for asymptotes of these graphs, if we are looking at our h and k, we just have to ask ourselves which one's your horizontal, which one's your vertical, and that's going to become your horizontal or your vertical asymptote. Okay, so here we have our denominator is x minus 3. That means we cannot have 3 in the denominator. So that's going to be a restriction in our graph. That also means that our h value, is 3. That becomes our vertical asymptote. Our vertical asymptote is going to be at x equals 3. Our horizontal asymptote is going to be the k value. This graph is shifted down 2 units or at negative 2, so our horizontal asymptote is going to be at negative 2. In a parent function, as you saw above, actually it's in your book, I didn't state it above. In a parent function, the vertical asymptote is going to be the y-axis and the horizontal asymptote is going to be the x-axis. So those are actually going to shift with your h and k values. And you'll notice your domain is related to your vertical asymptote. If we can't have a value at 3, everything else is acceptable. The domain is all values of x such that x is not equal to 3. Your range is going to be all values of f of x, or you can use y here. Y, all values of y such that y is not equal to negative 2. So in our next video, we're going to learn how to actually graph these. We're going to sketch a vertical and horizontal asymptote at these values, and it might help you see domain and range a little bit easier. And then part B. Here, our h value is negative 1 and our k value is positive 5. That means we have a vertical asymptote at x equals negative 1 and a horizontal asymptote at g of x equals 5. Make the connection to domain. If our vertical asymptote's at negative 1, then our domain is going to be all values of x such that x is not equal to negative 1. And same with our range. If our horizontal asymptote is 5, then our range is going to be all values of g of x such that g of x does not equal 5. And then a note, the vertical asymptote is at the value of x for which the function is not defined, which I've kind of said over and over again with these. So the next video, we're actually going to look at the picture of what a hyperbola looks like in case your book is not in front of you to match up with your key concept on page 545. We're going to sketch these asymptotes And then from there, all it is a table of values to create your hyperbola.